classified as number one, monohydric. What will be monohydric alcohols? So they contain only one OH group. Okay. Second classification is dihydric. They contain two OH groups. Third one is trihydric. They will contain three OH groups. Okay, they will contain three OH group. Last you will write polyhydric. Polyhydric. These contain more than three OH groups. Okay, they will contain more than three OH group. Right. There are some common monohydric and polyhydric, dihydric and trihydric alcohols that I want to show you guys, and you have to remember their names also. So one of the most common alcohol is ethanol. It is also used as a solvent. So you have to remember the structure also. CH3, CH2, OH. It can be written as ethanol. You may also see it as ETOH. So ET is short for ethyl and OH, and it is also known as ethyl alcohol. So you have to remember all of these three names. This is one of the important monohydric alcohol. Right, next. If you have two carbon atoms like this, CH2OH, then again you have CH2OH. This molecule is known as glycol. If you have the similar thing but with three carbon atoms, that means you have CH2OH, there is CHOH, and then again you have CH2OH. So all of three carbons are what? They are attached to each other. They have a bond between each other. So this will be known as glycol. And they can directly, sorry, this is glycerol. That's right. This is glycerol.
Sir,
Sir,
polyhydric contains more than 3 or more than 4?
No,
or
no,
4 or
three.
more?
No, no, more than 3. More than 3 you can classify as polyhydric. Why? Polyhydric is more than 3. Okay. Even you will see some people, they classify dihydric and trihydric also as poly, because basically poly is anything which is greater than 1. And it depends on the context also. For example, is triangle a polygon? Yeah, it is a polygon, right? But a line is not a polygon. So it depends on the context also, but this word here, it may also mean more than 1. Okay. Then, right, next. There is an important molecule which is a derivative of phenol. It is known as cresol. I hope you guys know what is phenol. So let me write 2 more things. Phenol versus benzyl alcohol. This is also very important to distinguish. So phenol will have a benzene ring with OH group directly attached to the benzene ring. But benzyl alcohol will have a benzene ring. This benzene ring will be attached to a CH2 group. This CH2 is now attached to OH. Okay. So this is phenol and this is your benzyl alcohol. This is benzyl alcohol. Please write this down. Now, a derivative of phenol, which is very important, it is known as cresol. So please write cresol. So these, whatever these common names are there, you have to remember these. Okay, you have to remember these. Try to learn it today only. What are cresols? Cresols are phenols with one CH3 group. Phenols with one CH3 group. Okay, on the benzene ring, we'll have a CH3 group. So cresol can be of three types. First of all, we'll make a phenol OH, and I will have a CH3 here. Now, since the CH3 is in the ortho position, it is known as O-cresol or orthocresol. Now you can have the CH3 group on the meta position. It is known as what? M-cresol. You can also have the CH3 in para position. It will be known as what? P-cresol. Will you write this down?
Sir, did you give anything before this?
We have done that. At the end, you ask me, okay? I will just ask you to take a screenshot. You have not done any conceptual part. We are just learning about some common alcohols and phenols. That's very special here. Okay. Leave some space, by the way, like half a page or something, and then you can start today's class. Now, after cresol, you will write dihydric phenols about dihydric phenol. That is important. Dihydric phenol. The only reason
So
we are
that
studying
the benzyl alcohol, can you show one, sir? Okay, sir. Thank you, sir.
Now, we have dihydric phenol. Okay, so dihydric phenol will be, you can again have three types. Here you have a phenol group, OH, and then one more OH is present in the, one more OH is present in what? In the ortho position. This molecule is known as, its common name is catechol. Now you have OH here. It is present in the meta position. Then it is known as resorcinol. The same OH group is present on the para position. Then it has two names. You have to remember both. Both, the one is hydroquinone, or the other name is quinol. Now till here the naming part is done, the common names and some important dihydric, monohydric and polyhydric alcohols. Now the next note that you are going to write, that is going to be very important from the perspective of the reactions also. We have not still started the reaction, but it is going to be important. Okay, so please write this down, then we will pay attention to whatever I'm saying in the note. And right next, write note. Okay. Write the statement with me. More than one OH group cannot be present on one carbon atom. On one carbon atom, as then the molecule becomes very unstable, and releases H2O. So for example, if you have CS3 and then you have a carbon atom which has one hydrogen which is attached with two OH groups, then what happens actually? What you will see here is, H2O molecule will get liberated. Okay, H2O molecule will get liberated. Now, if you want to know into the detail, let me show you how it is happening. Why the H2O molecule it gets liberated. Okay, the thing that happens here is we have the lone pairs of oxygen here like this, and then this hydrogen is delta positive. Now there is a very strong interaction between this hydrogen and this OH. Sometimes what happens, there is a kind of equilibrium here that it shifts towards CH3 carbon, and this hydrogen it gives a double bond to the oxygen, and you will have something like this. So there is a very slight possibility that this particular molecule can be formed because oxygen here is what? It is having lone pair electron. This hydrogen is delta positive, which is having electron deficiency. So the lone pair here can interact with the hydrogen delta positive charge and it can take this up. Now, as soon as there will be a positive charge in oxygen, it will automatically break off like this. Okay, so we directly write it like this. You can just remember if you have gem diol. How many of you know this about this sun sign Gemini? How many of you know about this sun sign Gemini? Have you heard of this, guys? Anyone?
So it's a star sign, right?
Star sign, yeah. Star sign, sun sign.
Yeah.
Yeah. Any others? No. No one
Kinda, yeah. I've heard of it. I'm not interested in it, but yeah, I've heard of it.
Heard of it. Okay. Does anyone remember what is the sign of Gemini? Does even no one knows the sign of Gemini? Can someone Google it right now?
It's like a pie, but both up and down.
It's like a what?
It's like a pie sign, but the dash is up and down.
Pi.
Yeah.
Okay. There is something else also. What symbol bhi hota hai kya kuch? Like for example, there are some lions for some star signs. I don't know. That is astrological sign. There is some symbol also.
Two heads, sir.
Two heads
What?
not facing each other.
Two heads not facing each other, right? So, I mean, generally it is known as twins. Okay, it represents twins. Similarly, here also, this is what? OH and OH. Now, in chemistry also, its name is what? It is derived from Gemini only. Its name is gem diol. When I was in 11th standard and 12th standard, my teacher used to always say this word. Now, the gem diol will be formed, and that is why water will leave. Gem diol will be formed, water will leave. So I was very curious, like, why do we call it gem diol? Like, what is the chemistry here? There was no chemistry, and rather I found astrology here, that this particular part here is gem diol, and whenever gem diol is formed, water leaves. Okay, so water will leave, and you will be forming what? A C double bond O. So you will be CS3, carbon double bond O, and if I write the H height like this, I will get an aldehyde. Now, in place of H, if it was a if we had CH3 with carbon and OH, and let us say here we had CH3 or any other alkyl group, then here also the water would have left, and you would have get CH3, carbon double bond O, and then CH3. That means you have got what? You have got a ketone, right? You have got a ketone. Now let us say if you have 3 OHs, you have CH3. Now this is rarest of rare case. Like just theoretically speaking, if you get something like this, like theory में तो आप कुछ भी molecule बना दीजिए, practically it is very rare that you get 3 OHs here. Now in the second OHs only the water will be leaving. But let us suppose you get this molecule somehow. So this will be CH3, and then what will happen? Then again OH will leave, right? OH will leave and you will get C double bond O, and this OH you can write here like this. So you get an acid, carboxylic acid. Okay, so one thing that you have to remember, so whenever you form a gem diol, water will leave. Okay, water will leave. Please write this down. Then we'll move on to the methods of preparation of alcohols.
Sir, I can show the definition also. The note, sir.
More.
No, I was asking the note.
No.
Sir, so these are called gem diols, sir.
Yeah. If you have 2 OHs on one carbon atom, that molecule is known as gem diol. General, this is a general. For example, if you have one OH group, then it is known as alcohol, right? So these are also alcohols, but inside alcohol you can have a category which is gem diol. Gem diol. There is a branch of studies which is known as etymology. Does anyone know what is etymology?
Yeah, like the origin of names, how they derive it.
Yeah, I think every student should be curious about the etymology. I mean, and also you don't have to like the process of etymology is more important rather than the answer. But you should be interested in names, like where is it is derived from. Like the answers are not very much important. That process is very important, like how you search for different names and how you connect different things. So you can connect like astrology with chemistry also, if you know these things, right? Now let us move on to. There is one website. It is ran by I think some, I don't know what's his age right now, but when I stumbled upon this website, he was somewhere around 16, 17. He's a guy. He's very much interested. He was in high school at that time. I think he's from USA or somewhere, and he has created a whole website. I don't know what's the website name. Can't remember now. And last year or last year, he got into Harvard, and his extracurricular activity was only this thing, that he was interested in etymology. Okay, now let us look at the methods of preparation of alcohol. Write the first method using haloalkane. Now write here with me. Please write this statement with me, okay? When haloalkane is treated with aqueous KOH or NaOH, they form corresponding alcohol. They form corresponding alcohols. So a general reaction you can write is RX plus aqueous. Important, aqueous NaOH or KOH should be there, aqueous KOH. Then I will be getting ROH. And this is the reaction that we have already seen, right, in the previous chapter. If you have, let us say something like this. So we have here bromoethane aqueous NaOH, and I'm going to get ethanol plus NaBr. Similarly, if I have something like this, chlorine plus, now instead of aqueous NaOH and KOH, you can also use AgOH. Okay. This reagent is not there in NCERT, but still it's good to have some reagents in your head. You will get here OH plus AgCl, plus you will be getting AgCl. Now a note here is that I have made 1 degree and 2 degree, but for the preparation of alcohols using 3 degree haloalkane, it is not very efficient. Okay, why is that? I'll explain, but first of all, write a note. 3 degree haloalkanes give a mixture of alcohol and alkene on treatment with metallic hydroxides. Okay, so MOH is metallic hydroxide in general. Now, the reason that it is happening is elimination and substitution. They have structurally same reagent. Structurally same reagent means that if you have nucleophilic substitution reaction, that means substitution reaction is happening, nucleophilic substitution reaction, then also electronically speaking and nature wise speaking, we have the electron rich reagent OH negative, right? So in base is also electron rich, nucleophile is also electron rich. That means it is structurally same. That means the component that is there, the charge that is there, it is same, but functionally they are different. That means base it abstract hydrogen, and nucleophile it is going to attack that carbon atom. Now before the attack, we can't tell what it is going to attack, right? What it is going to attack. Once it attacks, then we get the conclusion that okay, fine, this reaction is taking place. Then we get a mechanism and propose a mechanism that okay, fine, if I have a very big electron rich reagent, then it is most probably going to act as a base. But for example, let us have a 3 degree haloalkene, like this CH3 carbon, CH3 Br and CH3. Okay, Br and CH3. Now the difficulty here is that now it can happen that if Br leaves on its own, then we will not have a problem. OH negative is going to attack on the carbon atom, but it not happens always. Not all the molecules which are haloalkane, they will break the CBr bond automatically. Okay, so this now the OH is coming. It finds it difficult to attack on the carbon atom because of the hindrance that is present. We have three methyl groups. So what does it do? It takes one of the hydrogen from here. Okay, and it is going to. There are two types of attack it can do. It can do this white attack also. It can do the green attack also. Now let us see if it does the white attack here, then what it is going to happen. Here we are going to get CH3, and then we will have carbon, CH2 and CH3. In both the cases, from the white one also, this Br is going to leave, and if the green attack, then also the Br is going to leave. That's for sure. Plus, let us see if we have the Br one. If we have the green attack, then it is going to be CH3, carbon, CH3, and oh sorry, not Br. Rather, we'll have OH here. Right. Now there is a mixture here. You have alkene as well as alcohol. So that is why, if I want to prepare alcohol, then it is not a very good method, because if I want to prepare an alcohol that I need and I will aim for a pure alcohol. Then I will aim for a pure alcohol. But as for chemical properties, then you will always write that okay, fine, it reacts with aqueous KOH or aqueous NaOH, and it gives you alcohol. Whenever we are learning the chemical properties, you think in your mind that we have some waste material and we are just reacting it somewhere. Okay. But when I have to prepare something, if I have to prepare alcohol, then you will keep in mind that whatever method of preparation is there, they will keep in mind that it should be pure. Okay, it should be pure and it should not be forming mixtures. So you will write here one more point. Never prepare 3 degree alcohol using 3 degree haloalkane. or rather any haloalkane actually. So if we have a 3-degree alcohol, we want to prepare a 3-degree alcohol, then our way is not using haloalkane. We will not use the haloalkane. Okay, so write this down. This is the only new thing that you are learning in the alcohol chapter. Tell me.
Sir, can you explain again? I got stuck.
Okay, so I'm saying that since it is giving mixture, that is why we are not preparing alcohol using haloalkanes. Got it? Because whenever we are preparing something, you want it pure. You don't want any mixtures there. You want alcohol and the complete alcohol. Okay, so since it is also producing some alkenes here, and that is why it is creating a mixture. You got my point? Yes or no? Tell me.
Yes, sir.
Sir, what is MOH, sir?
Metallic hydroxides. Sodium is a metal, potassium is a metal, silver is a metal, and we have OH. So MOH is a short form for that in general. Write it fast. If you have not written, please write it fast.
Done, sir.
Okay. All of you will write next.
7
reduction.
minutes, sir.
Okay, okay. Done, guys?
Yes, sir.
Right, next. By reduction of aldehyde and ketones. Second one. By reduction of aldehyde and ketones. So actually what is present in aldehyde and ketone? The important thing is we have carbon double bond O. It is very easy. What we can do, we just have to break this pi bond and we have to add a hydrogen on oxygen atom and then add a hydrogen on the carbon atom. So we are addition of hydrogen is what is known as reduction. If I will do this and then I will be getting carbon. There will be one hydrogen that we are getting from the reducing agent. There will be oxygen and then this oxygen will also be getting one hydrogen atom like this, right? So this is how we are going to prepare. We are going to use any reducing agent. Okay, we are going to use what here? Any reducing agent, Ra. Please write with me. Please write this with me. Okay, when I'm saying write this with me, please write this with me. Aldehyde and ketones can be easily converted. To alcohols using a suitable reducing agent such as, I will write this reducing agent that we can use. Number one, this is also known as catalytic hydrogenation. Okay, it's known as catalytic hydrogenation. That means whatever reagents we are going to use, we'll have H2. Now this slash means it does not mean or, it means in the presence of nickel. Now we have or platinum or palladium. Okay, so if you have above the arrow like this H2 in the presence of, let us say, nickel, then it is what? It is catalytic hydrogenation. They can ask you also what happens when we do catalytic hydrogenation of aldehyde or ketone, then you will say that we form alcohols. Second one is LiAlH4. It's known as lithium, aluminium hydride. Third is NaBH4. Sodium borohydride. Right, next. Fourth is sodium in presence of ethanol. So it will be shown like this. Above the arrow, you will be showing here sodium in the presence of C2H5OH. If you have something like this, that means it is sodium in the presence of ethanol. Write this 4. Now write the reactions. Okay, you will write one more point here. Aldehydes give primary alcohol. Ketones give secondary alcohol. Okay. So again, we have not got any good method to prepare tertiary alcohol till now. So please write some examples are C double bond O and an hydrogen atom. So what you have to do? You have to add a hydrogen here and you have to add a hydrogen on this oxygen. You'll get R. This will be now CH2 and this oxygen will become OH. This is what 1 degree alcohol. If you have R, C double bond O and there is some R dash, that means you have ketone. If you have ketone, then again you have to do the same thing. Add a hydrogen on this carbon atom and add a hydrogen on the oxygen. You will be getting what? You will be getting R. You'll have carbon, OH, and since here we have hydrogen, we'll have CH and then R dash. This is a 2 degree alcohol. Now the important point to note down here is what is happening. What is happening here? We are breaking CO pi bond is broken. And what are we forming? We are forming CH bond and we are forming one OH bond. Both of these bonds are formed. Okay. So wait a second. Let me write the reagents here. So reagent, you can write H2 nickel. You can write LiAlH4. Okay.
Sir, if we interchange the regions also is no issue. Like the first reaction we use lithium aluminum hydride.
Yeah, you can use any 4. 4 लिखे हैं कि नहीं लिखे हैं आपने?
Yes, sir.
हाँ जी, लिखा है ना? हाँ. We can use any 4. This is a very important reaction, very good reaction also. You can convert from aldehyde and ketone directly to alcohol. Okay. चलिए, write some questions.
1 minute, sir.
जल्दी लिखिए, जल्दी. Try to write the product on your own. Product लिखने के लिए आपको देखना ना पड़े स्क्रीन. Reagent तक देखिए, product खुद से लिखिए. Because एक बार तो आपने समझाते हुए देखा है ना. Make this a habit. Done, guys? Yes or no? Please tell me.
Yes.
Yes, sir.
Okay. This is aldehyde. Okay. I hope you guys are comfortable with the bond line structure as of now. Sodium borohydride.
These are questions.
Yeah, you have to write now. टेस्ट नहीं ले रहे हैं, प्रैक्टिस नहीं कीजिएगा क्या? Remember what you have to, okay? Since we are not showing any carbon, like what carbon has how many hydrogens, you just need to focus that you have to break the pi bond between C and O, and you have to make an OH. So for the first one, it will be what? It will be 1, 2, 3 carbon, and then we have oxygen. So 1, 2, 3 carbon, then you'll be having OH. Then here also it will be same. All of these questions are very, very easy. OH. Next case we'll be having OH. So we had oxygen here. Oxygen छोड़ दिया हमारा. I hope you can see the difference between the second structure and the fourth structure here. It is a ketone here and it is a aldehyde here. So you'll have 5 carbon and then 6 carbon, and then you'll have a OH group. That's it. Now here, wherever you have a double bond O, we'll just break that double bond pi bond, and you'll form what? OH. Here you'll form 2 OHs on the 2 adjacent carbon atoms. OH and OH. And you can form here, yeah, we are 1, 2, 3, 4. 2, 3, 4. In the second carbon, we have double bond O, so there will be an OH here. The fourth carbon, we have double bond O, there will be an OH here. That is it. Sorry. Write a note. tertiary alcohols cannot be prepared by reduction of aldehydes and ketones. Done, everyone? All of you
Yes,
done
sir.
with the note? Okay. Right, next one. By
1
reduction
minute,
of
sir.
carbon.
Sir, could you show the note again?
I hope all of you understood how to make the product. Yes or no? Please tell me, guys. Yes, Samaira, Salman, Nawal, Hania,
Yes, sir.
Nishma.
Yes, sir.
Yes, okay. आप लोगों की आवाज नहीं आई? निश्मा, समायरा, हानिया. Yes, Hania.
Yes, sir.
Could not hear. Yes, okay. Acha, Hania, I have also messaged you regarding one of the questions. Did you see that?
No, sir.
नहीं, आपको नहीं किया. किसे किया है हमने फिर? एक सेकंड. I think it was you only, no? Yeah, I have.
I've seen it just now, sir.
You've seen it just now?
Yeah.
Okay. Right, next. By reduction of carboxylic acid and esters. Now, this is the third method of preparation. By reduction of carboxylic acid and esters. Now, please write with me. First of all, please write this with me. Carboxylic acid and esters are reduced to primary alcohol in the presence of a strong reducing agent, and that reducing agent is LiAlH4, lithium aluminium hydride. My teacher used to say lithium aluminium hydride is the you understand what it is mean? दारू का ठेकेदार. No one understands this. Those who know Hindi, they may understand. No one knows. That means it will turn anything to alcohol. Lithium aluminium hydride, it turns anything to alcohol. Okay. That is why he used to call it daru ka thikadar. Okay. Right, next. We have RCOOH. The structure of RCOH is something like this. I hope you guys know this. C double bond O, and then there is OH. We have lithium aluminium hydride. Okay, in the first step. In the second step, we will add water. Okay, we'll add water, and we'll be getting RCH2OH. RCH2OH. Next, if you have, let us say, for example, CH3, COOH, you only use lithium aluminium hydride, nothing else. Okay, I will be getting CH3, CH2OH. So what is happening here? the COOH is getting converted into what? COOH is getting converted into CH2OH. Okay. So wherever you see C double bond O and OH, you will convert it to CH2OH. Write some reactions. All of you wrote the product. Yes or no? Please tell me. For these two reactions. Okay. Right, next, esters are reduced to alcohol. And they give mixture of alcohols. Okay. So for example, you have R, C double bond O, and O, R dash. Now, in the presence of LiAlH4, but for esters, you can use the sodium ethanol combination also. Okay. So let me just write it. Okay. Now, here what happens actually, this bond breaks like this, and this oxygen gets a hydrogen, this carbon gets a hydrogen, and then this oxygen also gets a hydrogen, because we have an ample supply of hydrogen due to lithium aluminum hydride, which is a strong reducing agent. That means it will be giving a lot of hydrogens here. Okay, so oxygen gets a hydrogen, this carbon gets a hydrogen, and this oxygen again gets a hydrogen. So you can see that from this compartment here, from this side, what is the molecule we are getting? We are getting R, C, R, C. Will be getting one more hydrogen. Yeah, this one is getting one more hydrogen. C, H2, OH. And from this region, we are getting ROH. Rather R dash OH. Okay, so let me give you an example. If I have, let us say, CS3, COO, CS3. ठीक है, आपको एग्जाम में ऐसे ही दिखा रहेगा ना, पूरा डबल बॉन्ड हो ऐसे खोल के कोई तो देगा नहीं आपको, राइट? सो यू विल मेक, इन दोनों O के बीच में आप एक लाइन ड्रॉ कर लीजिएगा लाइक दिस. ओके, इन बोथ ऑफ दीज O, and then this will be one compartment. So you will be making CS3, CH2OH plus, from here you will be making CS3OH. Okay. Now, just a second. Yeah. So in this case, you can see that we have what? Bond will break here. You have two carbons here. That means you'll be getting CS3 CH2, OH. And here also we have 2 carbon atoms. From here also we'll be getting CH3, CH2, OH. Write this down fast. Here also you can use, let us see, sodium in the presence of C2H5OH. Right, next. Write a note first. Please write. The reduction of aldehyde ketone and esters using sodium in ethanol. Sodium in the presence of ethanol is called Bouvault-Blaine reaction. B-O-U-V-A-U-L-T. Bouvault-Blaine reduction.
So could you tell the spelling again?
B-O-U-V-E-A-U-L-T. Bouvault-Blaine reduction. Now, the fourth method that we'll be using here is you can put as many stars as you want. Okay, this is very, 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 very important. It's very important. And it's also important to understand this whole reaction. You can write by using Grignard reagent. By using Grignard reagent. Okay, right here, if you have, we need any carbonyl carbon, plus we need an RMGX. Okay, we need RMGX. Now here, what is going to happen? Please listen. We have R, which is delta negative due to magnesium is electropositive. It gives electron because of its metallic character. Now this carbon atom here, it is delta positive. There will be attack from the R group on this carbon atom. Okay, so rather than, let me show you this delta positive charge here, and let me attack from the downside. Now, as soon as this R will attack, what is going to happen? Carbon is going to form five bond, but carbon cannot form 5 bond. That is why it is going to break the CO pi bond. You have something like this. And further, you will be getting these bonds are intact. Carbon and oxygen pi bond is broken, and R group is now attached on the carbon atom. And now this oxygen is having what? MgX. And further, it is reacted with water. What we have here, we get the hydrogen here, and we get the OH here. So hydrogen binds with oxygen, and OH it gets attached with magnesium, and you get these bonds are as it is with carbon atom. There's a new addition of R group, which is coming from the Grignard reagent. Plus we have OH. Okay, plus we have OH. So this is the addition product. and this is alcohol. Okay, so please write. Please write with me. When Grignard reagent is treated with Grignard reagent is treated with aldehyde or ketone, they form addition product. They form what? They form addition product on further hydrolysis. On further hydrolysis, they form corresponding alcohols. Please write this down. Now, there are three types of reaction that can
Sir, 1
happen.
minute, sir.
जल्दी लिखिए. Done?
Yes, sir.
Okay, right here. So there are three different types of product that you can form by reacting three different types of reactant. The number one is formaldehyde. Okay, all of you will listen now. You will not write anything. You will listen here. So when we react Grignard reagent with formaldehyde, what is happening to formaldehyde? What is happening? We have here hydrogen, carbon atom, hydrogen, and double bond. Okay, so when we have, this is what methanol plus RMGX. Now this again R group will attack on this carbon atom, this pi bond will break, and what is going to form? We will be forming this carbon atom with the hydrogen as it is, O MgX, and here I will attach a R group. Where this R group is coming from? This R group is coming from my Grignard reagent. Please remember this R group is coming from Grignard reagent. Then on further hydrolysis, I'm going to form, we are having R, then we have CH2, and then we have OH. Okay, as you know that hydrogen will come here, and then OH will attach on this magnesium here. So we have R CH2OH. Okay, R CH2OH, and this R is again coming from where? It is coming from the Grignard reagent. Now, in formaldehyde, initially we don't have any, no R group. It leads to how much R group? One R group. Okay, you start with 0, you get 1. This is primary alcohol. This is 1 degree alcohol. The second case. In the second case, you will have what? Any other aldehyde. Okay, of all other aldehydes. All other aldehydes, you will have C double bond O as it is, but instead of hydrogen 1, they will have a R group, and the other hydrogen will be as it is. Now, when I'm reacting this with R dash MgX, this R dash is going to attack on the carbon atom. This pi bond is going to break, and you are going to form carbon with its R and hydrogen intact as it is, it gets OMgX, plus this carbon gets an R group which is coming from an R dash group which is coming from the Grignard reagent. Further on hydrolysis, we get R carbon CH, okay, and then we again get an R, and this carbon atom is having the OH group. As you can see, R, C, R, and then we have the OH group. Okay, so this is actually R dash, right? R dash here. So this is 2-degree alcohol. Also remember this R dash is coming from my Grignard reagent. Now let's look at the third one. If we have ketones. Now please think in your mind what is going to happen. Okay, so ऐसे बिल्कुल देखते मत रहिए, because you guys are not interacting now. You should think in your head what is going to happen. In ketone, we'll have the same group as it is, and we'll have, let us say, R dash, and let us say we have R2 here. Plus I'm reacting this with R3 MgX. Now this R3 will attack on this carbon atom. I will be getting carbon R1 and R2 as it is. And then we have R3 also. Further on, we have OMgX. Then again on further hydrolysis, what are we going to get? We are going to get here R1, then we'll have carbon, we'll have R2, we'll have R3, and there will be OH. So this is 3-degree. And you should know that this R3 is coming from my Grignard reagent. So this will be 3-degree alcohol. Can you please write this down? Now in all other aldehyde, you can see that we have one R group, 1R to 2R. That means 2 alkyl groups. In ketones, we have already 2 R groups, 2 alkyl groups, and we are moving to 3 alkyl groups. Okay. So write this down, please, fast. Done, guys? Please tell me.
No, sir.
Done guys, yes or no, please tell me. जल्दी लिखिए. चलिए. Let us move on now. चलिए, write some questions. Okay, also write in the second step, you are using H2O. Wait a second. ऐसे लिखिए इसको आप. First step में dry ether, second step में water as a solvent. Okay, both of these are solvent. The first step, dry ether will be solvent. Second step, H2O. Same here and here also. Okay. Products बनाइए. If you have any difficulty, then please let me know.
Sir, in the product, we don't need to write that MGBR, right? What happens to MGBR in the product?
No, you don't have to write about that.
Okay, sir.
Please try कीजिए, okay? I want all of you to make the products. At least try something. And if not, then please look at the previous reactions, whatever we have done, how we have moved the arrow. Try moving it. If you're not understanding, you have to ask me now, because this is the second chapter. Everything has been taught in the first chapter already. Which carbon is going to be the reactive carbon due to the electron deficiency, which is going to be which is going to have more electron density. All of these things have been taught. Okay. You have also seen all of the 3 cases.
Sir, should we send you these answers?
Yeah. I mean, if you want to check, है ना, देखिए, see, second chapter से हम उतना force नहीं करते हैं किसी को. If you want to check your answers whether it is right or wrong, then you have to send it to me. Because from now you should be serious. You have all the tools with you. Sure. So all of you will check your answers here on your own, I think. So the first one, CS3 here will attack on this carbon atom. Okay, and then we will be getting here CS3. The C double bond O will get OH, and you will get the CS3 from the methyl Grignard reagent. And the second reaction also, the CS3 will attack here. Now in this case, we will be getting here CS3, COH. This CS3 is as it is, and then
Sir,
the
in the
CS3
first
is
case,
coming.
carbon will have H also, right, sir?
Yeah, it will have H also. Get a CS3. The third case will have oxygen here, hydrogen here, and then there will be a CS3 here. In the fourth case, we have here carbon. This is the Grignard reagent. So actually, this Grignard reagent will be like this. It will attach to this carbon atom, which is having 2 hydrogens, and then it will have OH. So this is the product that we will be forming here. Yes, Nabil, very good. All your answers are correct. Very good. Now, और किसी ने तो नहीं भेजा है? Yeah, no one else has sent. Right, next question. Suggest a suitable Grignard reagent for the preparation of following alcohols, following alcohol using methanol, using methanol, and they have given two. Number one is CH3, CH, CH2OH. We have here CH3, and P1 is we have CH2OH. Okay, they're asking what is the proper suitable Grignard reagent. Okay, now you have to think of this reaction like this. Let us look at the A case. They have given you the product. So we are going to form this alcohol. That means they have given you the product. So write it as a product. CH3, CH, CH2, and CH3. I have to use a Grignard reagent. Okay, plus methanol. So we are treating what? We are treating Grignard reagent and methanol. So what is methanol? Methanol is C double bond O, and there will be two hydrogens. There will be two hydrogens, right? One carbon atom. Product is this here, OH. Now, as you can see here, Grignard reagent, it does not contain any oxygen atoms. That means this part here, this carbon and this oxygen, it should be coming from where? This carbon here and this oxygen here, it is coming from my methanol. Now, whatever else is there, that is coming from Grignard reagent. So what is present else? This whole part is coming from Grignard reagent. So you will take that part as it is. You will make that part as it is. Okay, don't have to change anything there. You'll write it like this: CH3, CH, CH3, and wherever you have broken the bond, you will write here MgBr like this. MgBr like this. If I look at the second one, it is more easy. I have this group here, cyclohexane. Then I have CH2OH. Here also they are saying what? I am going to use methanol. What will be my Grignard reagent? So I can see that this carbon atom and this oxygen atom, they are coming from our methanol. Whatever is remaining, that means this portion till here, it is coming from your Grignard reagent. So your Grignard reagent will be MgBr. You have to put down MgBr from wherever you have broken the bond. Okay, so you will write MgBr. You'll write MgBr. Chali, write for these two. Done, guys. Yes or no? Please tell me.
1 minute, sir.
Actually, I hope everyone is done till now. So in today's class, we learned about methods of preparation, right? Methods of preparation, we started with haloalkene. Then we looked at what? What did we look at? The second point, reduction of aldehyde and ketones, right? If you have R CHO, or if you have R C double bond O R dash, okay? Or rather, I should say something like this. If you have carbonyl compounds with C double bond O, right? Then we saw for carboxylic acids also and esters also. If you have COOH and if you have R COO R. So here we use aqueous KOH or NaOH. Here we use any reducing agent such as H2 nickel. Here we can only use LiAlH4, and here we use what? Both LiAlH4 or sodium in C2H5 OH. Then the important thing that we looked at today was if we have plus RMGPR, then I'm going to get what? R CH2OH. Okay, so formaldehyde 1 degree, any other aldehyde 2 degree. Okay, and if you have ketone, then it is going to give you 3 degree alcohols. So that was the main point of today's class. Okay,